An object of mass 5 kg is sliding from this frictionless surface, which is, as you see from, is making angle 30 degree from the horizontal. And in this question you have to calculate the work done by the weight. Now while calculating, we will not directly apply formula of the work W is equals to mgh, right? We have to see that what is a concept of work. Work done is a product of the displacement, or the displacement from initial, the distance from initial position to the final position in a straight line, and the component of force that exerts in the direction of displacement. All right, so force in the direction of displacement and the work, and the displacement. All right, now when the object was at this point, when we released it from the rest, okay, and it is sliding on this frictionless surface, so it means that if we at any instant, if we make, let's say, because you know that our rectangular coordinate system on this ramp is basically also tilted by 30 degrees, okay, remember that. And what is the direction of its weight? That is always vertically downward, so this is mg, okay. And the other force is the normal force that is exerted in this direction. So this normal force, you know very well, you had already covered in A2, that this normal force will be balanced by the vertical I mean the y-axis component. So this is 30 degrees and this is mg cos 30, and this one is mg sine 30 degrees. So dear students, this mg sine 30 is the key important force which is doing work. So when they say the work done by the weight of the body, so that doesn't mean that the work done by mg, okay. So this is basically mg sine theta is doing work, because this is a force that is exactly in the direction of motion. All right, so according to this, if we apply this equation while calculating this, so which force is in the direction of motion? That is mg sine theta into the displacement, that is obviously the length of the ramp. Okay, so let's put the values. So 5 times, let's say 10, and sine 30 degrees times 6 meter, so this will result 25 times 6, that is equals to 150 joules. So this is the positive work. All right, and let's assume if there's the friction also, then this work will decrease. How much work will decrease? In that case, you have to find out work done by friction, that will be a negative work, and then you have to subtract it from this one, okay. So of course some energy will be lost, and this work done that we have calculated will appear in the form of gain in kinetic energy and loss in potential energy, okay. So I hope you understand.